So we did complete that earlier.
Not bad. Okay, so ideal gas law. Times V equals N times R times T. So as I was saying, pressure should be measured either in pascals or atmospheres. At this point, we should talk about the conversion between the two. 1 atmosphere is equal to 101,300 pascals. Okay? Yes. So whether you use pascals or atmospheres is going to determine what other number you use, as we'll talk about in a minute, but it's easy to convert between the two as well if you know this conversion factor. Okay? So V, volume, should be measured in liters, and T, temperature, always should go in as Kelvin. Okay, you may be given temperatures in Celsius, but that's why we learn how to convert between Celsius and Kelvin. In the ideal gas law, when you put numbers in, those should go in as Kelvin every time. So make sure you're doing that conversion if you're using this. Okay, N in this case stands for the number of molecules. So here's the question. What units would we use to measure the number of molecules?
Moles.
Moles, yes.
So R Rasputin's.
R is not Rasputin's, no. R is the ideal gas constant.
If you look at 7.35. E. Yeah.
The ideal gas constant, the number that you use is going to depend on whether you're using atmospheres or whether you're using pascals. Okay? So for atmospheres, so if you use over here, you're going to use atmospheres for your pressure. Then the ideal gas constant that you want to use, and I always got to look up the atmosphere one because I don't use that as often, is 0.0821.
You answer.
Yeah. Okay. The units for that, because it's a gas constant, the units have to go in to cancel out all of the rest of the stuff. So the units for the ideal gas constant are going to be liters times atmospheres divided by moles times Kelvin. Okay, and the whole point is when you are going to put these other numbers in, these certain ones should cancel out so that the other thing that you're calculating is going to be left. So for example, if you're going to calculate the volume, then atmospheres, moles, and Kelvin should all cancel out and you should be left with liters there. So what this can help you with is making sure that you are putting in the correct units when you're putting in the other numbers. We see our temperature has to be in Kelvin for this constant to work right. If you're putting in your pressure, if you're going to use 0.0821, then your pressure has to be in atmospheres. Okay? So we could just use this gas constant and always convert our pressure from pascals into atmospheres using this number over here.
But I feel like pascals are used more frequently, so...
Pascals are used more frequently. Atmospheres tend to be easier to understand because it is based on, a single atmospheric pressure at sea level. But we do have another gas constant that we can use, but the number is going to have to be different if we're going to use it in terms of pascals. So if we use pascals instead, then in this case, the number that we need to use is 8.314. And for that one, the units are going to be very similar, but it's going to be liters times, pascals over moles times Kelvin. Okay? So which ideal gas constant you use doesn't matter that much, but you have to match it up with the pressure that you're using. Both those will be on your equation sheet. along with the ideal gas law. So it's kind of up to you whether you are more comfortable, say, converting back and forth between pascals or atmospheres, or if you'd rather just stick in a pressure and pick the right gas constant to put in. But if you mix those up and you use the wrong one, your answer is going to be way off. Okay?
We have 4 whole answers to do.
Wonderful.
Sorry.
Oh, I actually forgot something. This is supposed to be not pascals, but kilopascals. Sorry about that. Get ahead of myself.
That changes the whole thing.
That does change the game a little bit. Only by 1,000. So if you're going to put it in into the equation, then you need 101.3 kilopascals. Okay, so maybe we should write that down. So this is equal to 101.3. But that's split up through that conversion. You're just moving the decimal over 3 times. So that's the ideal gas law. That's pretty much all there is to it. But what this does is take into account everything that is going to affect that gas. Because in the combined gas law, there we were just looking at a single sample of gas and how it changes. So the biggest thing on these types of gas problems that you're going to have to look at is figuring out which gas equation to use, which gas law. The combined gas law is for looking at changes of a certain gas. So it says, hey, you have this sample of gas and you change something about it. What's the new temperature? What's the new pressure? There you would use the combined gas law. In this case, this is made for calculating the specific characteristics of a gas, at a single point. So this doesn't have anything to do with the gas changing its characteristics or changing its measurements. It says, hey, you've got this gas, there's this many moles in it, it's at this temperature, pressure, what would the volume be? Okay? So our homework for tonight is going to be using the ideal gas law. But down the road, we're going to have to do some where you're having to split them up and figure out which gas law to use. Something to add, Mr. Kleindl?
No, I just thought of something I have to do that about.
Imagine that. So, homework for tomorrow, you can do the next worksheet, maybe all problems based on the ideal gas law. So, what is that, 12.2?